For years, astronomers suspected that the early universe was far more active, complex, and structured than our models allowed. But suspicion is one thing, proof is another. Now, the James Webb Space Telescope has delivered that proof. In the depths of cosmic history, Webb has uncovered a galaxy so ancient, so luminous, and so chemically rich that it forces us to rewrite the rules of galaxy formation, and perhaps even the story of the universe itself. This discovery isn't just about one object in space, it's about what it represents. Clear evidence that the universe's first billion years may have been a frenzy of creation, complexity, and order, far beyond anything we ever imagined. And as Webb pushes deeper into the darkness, one thing has become undeniable. What we suspected about the deep universe may have been true all along. Back in 2022, the most distant galaxy ever seen was GNZ11, discovered by Hubble. Its light had traveled over 13 billion years to reach us, a milestone. But then came Webb. With its massive 6.5-meter mirror and infrared vision designed to capture the stretched light of the earliest galaxies, Webb quickly shattered Hubble's record. It spotted a galaxy called JD's GSZ10, sitting at a redshift of 1432, just 280 million years after the Big Bang. Then, Webb found something even stranger, a galaxy named MOEM Z14, with an even higher redshift of 1444. On paper, this was already astonishing. But the real shock came when astronomers looked closer. MOEM Z14 was tiny, just 500 light-years across, but blindingly bright. A furnace of newborn stars burning with an intensity no galaxy from that era was supposed to achieve. Our models assumed such galaxies would be faint, slow to form, and chemically simple. MOEM Z14 was none of those things. Webb's spectrograph revealed an unusually high abundance of nitrogen, a chemical fingerprint suggesting that multiple generations of stars had already lived and died before MOEM Z14 even existed. This was a revelation. It meant galaxy evolution began far earlier than we thought possible. To see nitrogen at these levels meant that supernova explosions had already been enriching the cosmos with heavy elements for hundreds of millions of years. Webb had essentially uncovered a hidden chapter of cosmic history, written into the chemistry of a galaxy shining from the edge of time. But the surprises didn't stop there. Galaxies with this kind of intense star formation almost always have a supermassive black hole at their core. Yet Webb detected none in MOEM Z14. No radiation, no gravitational signature, nothing. It was as if the galaxy's stellar engine was running at full throttle without the central mechanism we thought was essential. This challenges one of astrophysics's most accepted ideas, that galaxies and black holes grow together. If MOEM Z14 can exist without one, maybe black holes aren't as critical to early galaxy growth as we believed. Or perhaps this galaxy was caught in a fleeting moment, just before a black hole was born at its heart. Before Webb, galaxies like MOEM Z14 were thought to be extremely rare, statistical outliers in an otherwise quiet early universe. But now, they're showing up more often than expected. Each one undermines another assumption. If small galaxies could form stars this quickly and enrich themselves this early, then the first billion years of the universe must have been far more dynamic than our textbooks describe. And this doesn't just tweak the edges of our models. It forces us to reconsider their very foundations. Simulations of early galaxy growth will need to account for higher star formation rates, faster chemical enrichment, and possibly entire phases of evolution we've never imagined. As Webb's surveys expanded, MOEM Z14 stopped looking like an outlier and started looking like part of a pattern. Dozens of compact, ancient, luminous galaxies began appearing in the data. Some were even richer in heavy elements, hinting at an even longer cycle of stellar birth and death before the so-called beginning. This wasn't supposed to happen. In the Standard Model, the early universe was just chaotic clouds of hydrogen and helium, gradually coalescing into stars. But Webb is showing us something else. A universe that wasted no time building complexity. A universe that may have been structured and active almost from the start, and the surprises go even deeper. A separate study revealed something that ties disturbingly well into Webb's findings. Most galaxies appear to rotate in the same direction. That's not what we expect from a random universe where spins should be evenly split between clockwise and counterclockwise. This hints at large-scale coherence, an underlying order to cosmic structures that challenges the principle that the universe has no preferred direction. Could these early galaxies, rich in metals and bursting with stars, be part of a grander cosmic architecture? Some scientists are even revisiting a radical idea. What if our universe exists inside a black hole? In this framework, the Big Bang wasn't the beginning, but the rebirth that happens when matter collapses beyond a critical point in another, larger universe. This could explain why physics seems so finely tuned for galaxies, stars, and life, and why we're seeing unexpected order in the earliest structures, and then comes the most unsettling interpretation of all. Some researchers are beginning to ask, is the universe aware of its own evolution? The symmetry in structures, the coordinated galactic spins, the rapid chemical enrichment, these may not be random at all, but signs of a system that is self-organizing at the largest possible scale. In this view, every star, every galaxy, every conscious being may be part of a cosmic feedback loop. The universe observing itself, adjusting, and growing in complexity over time. If that's true, Webb's discoveries aren't just rewriting cosmic history. They may be hinting at a deeper truth, that the universe is not indifferent, but participatory, and that we are not separate from its purpose, but embedded within it. For decades, astronomers whispered that the early universe might not match the quiet, simple picture painted by our models. Now Webb has confirmed those whispers and turned them into undeniable evidence. Galaxies forming impossibly fast, structures richer than they should be, patterns hinting at cosmic order, and maybe, just maybe, a self-organizing universe. These aren't isolated curiosities. They're threads in a much larger story, one that challenges the very foundation of cosmology. If the early universe was richer, faster, and more structured than we thought, then the origins of galaxies, stars, and even life may be tied to forces or intelligences that transcend our current understanding. Webb hasn't just expanded our view of space. It has cracked open the door to questions we've been too cautious to ask. The evidence is here. The suspicions were right. The only question now is, are we ready to follow the truth wherever it leads? Let us know in the comments. Do you think these discoveries hint at a designed, evolving cosmos? Or are we still underestimating the raw, chaotic power of nature? If you found this as mind-shattering as we did, hit like, subscribe, and share this with someone who still believes the universe is just random dust and darkness. Because out here, in the oldest light of the cosmos, the truth is finally coming into focus. And it's more extraordinary than we ever dared to imagine.